Hello, myself Ved Prakash. I am here to give you physics lecture. Now you can see in your screen that with the video, a simultaneous boardwork position has been mentioned in the video. So you have to look over this both of these slides and the video part section of our presentation. So our today's topic is fluid mechanics for class 11. Let's move on to the topic over here. So as you can see in the board that two words specifically mentioned over here, one is fluid, another is mechanics. Specifically, these two words are depicting that the different kind of statics as well as dynamics of fluid will be discussed in this particular chapter. So to start with this, we have to first know about the fluid definition. So to be very specific, fluid is a substance that responsible to flow in a certain direction due to an external force applied on them. So basically, fluid has no its own structure of position. That is, in whichever container you pour it or you keep it, it holds the shape of this particular container or vessel. So fluid is of two types. One is gaseous fluid, another is liquid. So from your presentation, you can also see that the fluid mechanics is all about the study of two different chapter or two different view of fluids, that is the hydrostatics and hydrodynamics. So from the name suggests that hydrostatics is related to the study of fluid when it is in rest, and the hydrodynamics relates to the study when it will be in motion. That is, the fluid is in motion, then we will study the dynamics phenomena, dynamic characteristics of the fluid. So here I have also mentioned the topics in this particular lecture is going to be covered. Now, moving on to the first part, that is the pressure inside a fluid. So, we all know about the basic definition of pressure. That's, suppose you consider an area like this and you are putting a pressure or a force say F. We know force is a vector quantity. It is applying on the surface, say S surface. Now, whatever area is applying on this, that will be in our consideration. So, pressure is defined the force applied per unit area, to be very specific. Now, whenever we are considering the whole surface, then we go for average pressure. The average pressure is all about the smallest change of force or smallest application of force in per small change in area, in per small change in area. Now, whenever we are considering this from the definition of differential, it can be noted that this difference can be termed in terms of del F by del A, considering a limit of del A tends to 0. So as the area of the surface is squeezing towards unity or tends to 0, the average pressure can be measured using this formula by applying the differential law. You can also feel that a very well example has been shown in my slides, that whenever you are pinching your skin, you are touching your skin like this with a finger, then you feel a pain. But when the syringe, the needle of the syringe is pressed inside your body, then it hurts more. Why it's so? Because whenever you are pinching with your finger, then this quantity, that is area, is larger, but force is same. But whenever you are using the needle, the syringe needle, then it gets lowered. So the amount of, as the amount of force is same over there, so the pressure actually increases. So we feel the pressure more heavier. Now to going over the specific definition, after specific definition of pressure, we are moving to two different types of pressure. One is atmospheric pressure and another is gauge pressure. Now we have to know about these two terms very specifically, that the pressure that an earth exerts or an earth experience, our earth experiencing the pressure, is known as atmospheric pressure, and the excess pressure above the earth's surface, above the earth's atmosphere, not exactly the surface but also but the atmosphere, the earth atmosphere, that is known as gauge pressure. And cumulatively this atmospheric pressure and the gauge pressure is termed as absolute pressure. Now here in the slide I have shown three different cases of operation. Now this type of representation in my slide will definitely help you to solve different kind of problems, specifically those who are preparing for their different kind of all India level entrance exam. This kind of representation will help them to commemorate that how to tackle with tricky problems of physics with it. So these three types of representation of fluid has been shown over there. Consider a vessel filled with water, and in the first case we are showing that, in the first case it is shown that a very on a horizontal plane, on a horizontal plane, same plane, 2 points are considered. This is a same plane, 2 points are considered. Now the pressure experienced by these 2 points on the same plane will be the same. The condition is the velocity should be constant, the fluid velocity, if it is moving, or the fluid should be in rest. Now in the second case, here it is, in the second case, consider that 2 points are in a different depth, that is, one is P1 is separated by P2 at a height of h. Now the pressure at these 2 points on the difference level difference, that will be rho gh. Here rho is the density of the liquid, g is the gravitational constant, and h is the height difference between the 2 points of our consideration. Now here is a very important case which you sometimes come across, that is, consider a fluid is moving, consider a fluid vessel is moving with this one, consider the fluid is moving with a direction and acceleration a along this direction. Now it is quite obvious, you have seen in your real life example, that whenever you are moving with a glass full of water, then if you are moving, the upper surface of the water keeps moving to and fro in the along the direction of which you are moving. So in this case the fluid is also creating an angle of theta with the upper surface of the liquid. Now the vessel has two different pressure points. We are considering two different pressure points, P1 and P2, separated by a distance of L, and the pressure experienced at P1 is P1 and P2. Now the resultant pressure will be P1 minus P2 rho AL, where theta can be measured as tan theta by A by G. Here A is the acceleration with which the vessel is moving and G is the gravitational force, gravitational constant. Now here I have a simple question about for your practice, that I have shown, that is either it is moving with backward or forward direction. Now if instead of this backward or forward direction, if the vessel is moving upward or downward, then what will happen to these points, that is pressure point of P1 and pressure point of P2, separated by height h. Now this is very easy to see, that whenever that will be the, for your reference I am just giving you a basic hints for calculation. If you consider the point P1, this is the scenario. We are moving with the 2 points P1 and P2, and this is separated by a distance h. Now if you are moving upward, the main concept is, I am not going to the depth very much because it will be discussed in the full lecture slides. The main concept is, when you are going to the upwards, then you are adding your acceleration with your, that will be the effective acceleration. But when you are going downward, that is against the G, and in this direction it will be, the G, and it will be the A also has the same direction, but here A will be the opposite direction with respect to G. Now the case is, you have to consider that what is actually happening with this one. So the P1 minus P2 will be calculated from this as well as from this also. So I have just given the hints, you have to do it on your own. So here it will be G minus A or A minus G, vice versa. Now moving to a very interesting and very useful instrument which is responsible to measure the static pressure, specifically the static pressure of a fluid or specifically the gas. This is, I am talking about manometer. You can see in your slide a picture of manometer has been given. A gas filled chamber or vessel is put together with a U-tube, and inside the U-tube a manometric fluid has been put, and now one end of the manometer is open to the atmosphere and the other end is exposed to the gas, so that we can measure the actual pressure exerted by the gas. Now in this case you can easily understand that the gas is exerting its pressure in this direction, right? And the manometric fluid is in rest. Now whenever it puts pressure in this direction, then the manometric fluid will experience a rise in this particular direction. Now with this rise, that is rise from H dash, that is rise from position 2 to position 3. Now this difference will be actually responsible for the pressure experienced at the point 1. So it is quite obvious that if we are interested to measure the pressure at the point 1, we have to measure the pressure at the point 2. Now the actual pressure at the point 2 will be the height difference of 2 to 3, that is the pressure experienced at the point 3 is the atmospheric pressure, and the pressure experienced at the point 2 is the pressure exerted by the gas. So the difference in between this, we have to consider the height difference in between this. Now if we are interested to measure the pressure of the gas, then we have to measure the pressure at point 2 plus pressure at point 3. So in this process, in my slide it is already shown that the pressure is being measured over here. If you are experiencing any problem, please feel free to put a comment or WhatsApp me, whatever is feasible for you. So now we are moving to a very famous Pascal's law. This is a very basic law depending on which principle the fluid exhibits its characteristics of existence. Pascal's law actually states that whenever you are putting a pressure on an enclosed vessel, a closed vessel, whenever you are putting a pressure at one point you are putting a pressure. Suppose this is a, say, cylinder with a piston, or you can consider the example also shown in the slide, that shown in the slide. So as the cylinder moves to and fro, now you are putting pressure onto it, just on the tip only you are putting the pressure. So the cylinder comes below this, and as a result of this, suppose say in this point, but in this particular point it is experiencing, in this point of say A, the cylinder is experiencing a pressure. So from this point the pressure will distributed in all the direction in same manner. In all the direction the pressure will get distributed. This is only described by Pascal's. A very interesting applications of this Pascal law has been seen in the automotive industry, specifically in the automotive service industry, particularly for four-wheeler. As you can see in the slide, that particularly for four-wheeler servicing purpose, they need a car lift. You have shown in the car servicing area that there are different kind of car lift particular platform is over there, and with some operating some machineries, they lift the car and they service it, wash it, and they put down the car to the platform, and the customer takes the car away. So this is not so easy, as a car is very heavy, so this is not so easy for a car operating system to operate this very easily. So you can see from this example, you can see that the car is actually resting on a platform which has a larger area, this area is quite larger. You can see from this that this area is quite larger with respect to this one. This is very larger. Say here it is shown that say it is 10 times larger. Now you are just only you are putting a force over here. So at this point you are experiencing a pressure of P1 which is F1 by A1. Now from the Pascal's principle we all know that pressure are same on the in a closed vessel. As this is totally a closed vessel, the pressure is same. So in this end, in this particular end of the car, the pressure will be same as P2 equal to F2 by A2. So now from this only the pressure required will be F1 equal to A1 by A2, A2 which is 10 times of A1 and F2 by 10, that is with the 1/10th pressure, that is the force required to lift the car. The force required to lift the car is will be 10 times of the force exerted in this end. So this is the advantage. This is actually the advantage of this method, that A2 if as A2 is much larger than a small force is applying on F1 with some lever or some machineries, but the force experienced on the side of A2, that is the second side on which the car is resting, it will be a great amount in nature. This is a very famous syringe based model. Actually mechanical engineering people normally do this in different kind of projects, different kind of college projects, or kind of science science experience, sorry, uh, science related festivals. So this is all about now this is all about till for today, and then my next class I will be discussing about Archimedes principle. So thanks for watching my video.